Hi people, let's look at this question here, which was taken from the year 2020, which is this year at the time of recording. The NJC, basically J2, their common test 1, question 2. Okay, let's look at how do we solve this. This is on Maclaurin series small angle approximation. I realized that I have not, I just copy paste from one of the scanning here, but as you could see that the writing is all here. Okay, but it's good. Anyway, okay. Now a teacher is conducting a lesson on angles. She asked Bob to verify the angle of the elevation. To verify the yada, this is the Bob stood at this taken as shown below. Very good. The angle BAP, BAP is beta, and the height of the building OA and the distance AP are fixed constant. So if this is a fixed constant, just highlight this is a fixed constant, and this is a fixed constant. What's a fixed constant? AP, yeah. Oh, AP is A. Okay. Yeah, makes sense. It looks like alpha to me, but okay. This is a fixed constant. OPB forms a straight. Okay. Now the first thing is show that AB is A over cos B K sine B. Expressed in terms of theta. Okay, sure. Now, what I would suggest is this. Know what do you want. So you need an AB. Where's AB? AB is here. This is AB. Always look at what you want. So this is AB. Yeah. Okay. Then this is what you want. It's part of the equation here. Then you have got A here. Okay. This is A. I thought I drew this graph. Sorry. This is actually one of the NJ students working. Okay. So now, if you want to do such a question, right, you need to see the length and the angle. Take a chill pill, right? If you're stuck, right, you just know two rules that you need to know. One is the sine rule, and the other one is the cosine rule. So sine rule is very simple. Sine rule is, we like this rule here, which is like, well, rubbish. Sine A over A, sine B over B, sine C over C. Then you have A squared equals to B squared plus C squared minus 2BC cosine A. Now, is the cosine rule and sine rule formula in MF26? You go and figure out yourself. Spoiler alert, the answer is no. Okay, so basically you need to memorize the cosine rule and sine rule. Either way, I don't think, maybe I may be wrong, I don't know. Go and check. Okay, okay, so this is sine rule and cosine rule. Now, when you have more length than angle, so you see this is two length involved, right? And basically you have like the angle here. Likely is using cosine rule. Okay, so I really have not done this question before. This is my first time seeing this question, but this is a very common question they like to ask. So what you need to do is then, because you're given alpha here and they have beta here, then you get all the rest to involve. Okay. Oh, but no, this is not cosine rule already. Now I see sine rule. Now I changed my mind. It's sine rule because now you have a lot more angles that you used to. So this is pi. This is pi minus theta. I never copy her answer. I never copy her answer. This one here is theta minus beta. Same thing. I never copy her answer. Okay. So, and no I did . So anyway, you just take pi minus of this and this, you get that angle there. Okay. Then what you need to do, right, is just use. Now the reason why I need to find this angle here and this angle here is because if you want to use sine rule, your opposite pair have to exist. So that's why we do that. Wow, I'm so thankful that we are doing pure maths. Pure maths is like not much reading. Yeah. So this part here, by using sine rule, we get part 1, right? We get opposite. So sine theta minus beta over AP is equals to sine pi minus theta over AB. Am I right? They want AB, right? Yeah. So AP is A. So just get all the rest of it done. So it's quite promising, my equation here, but also not that. Oh, so K is a constant. and k, because no, the reason why I know that I need to take note of the constant is because now now I can this is how my brain works, right? So you know that when you expand this, you would have like sine A plus sine B, sine A cosine B minus cosine A, and so on, and you expand this, it's the same thing. So the reason why k is a constant, so you must take note that there are likely more trigo ratio here. Then they told you that sum of the angle is actually fixed. Is there a fixed angle? There's no fixed angle. Oh, in terms of anyway. Oh yeah, okay. Theta, k is a constant expressed in theta, but theta is not fixed, right? Okay, okay, doesn't matter. So k is in terms of theta. So beta is supposedly the what do you call it? The variable. So this will be sine theta cosine beta minus cosine theta sine beta. Okay, then the AP will be A lah. This is A. Then this is sine pi. Okay, you just have to expand. Slowly expand. This is sine pi, sine cosine theta. But this is sine pi is 0. And then you have minus cosine pi sine theta. Cosine 180 is minus 1. Yeah. So this would be just to. So this one will be minus cosine theta sine by beta. This AB would be what? AB would be AB lah. This will be 0, so this will be sine theta. Ta-da! So what I want is actually my AB to be alone. So AB will be alone would be sine theta over A. Sine theta cosine beta minus cosine theta sine beta. Okay? And because you see this A is alone, so what you're going to do is actually just, this is like your secondary school multiplication. So I'll just multiply both top and bottom with sine theta. Sine theta, then this would actually, AB would just be A over cosine beta minus cot theta sine beta. Okay, so this is it. So hence, K is a constant, it's cot theta. Yeah, okay, that's the first part. It's only 2 marks, my goodness. Yeah, so this is how you solve it. Then after that, great. Given that B is successfully small angle, show that this. Okay, B is successfully small angle, show that this. All right. How So now let's look at this. If it's successfully small. I'm just gonna slowly write now. Okay, so part 2. So we have AB equals to A over cosine beta minus cot theta sine beta. This part here interesting. So what we need is actually in terms of betas, cot theta. Wait, cot theta. What's the cot theta? In terms of K. Oh, okay. So this is a K lah. Okay, great. So we just leave it in K lah. So in terms of K, so we don't need to make it so this is A cosine beta minus K sine B lah. K in terms of K, is that in terms of K? So we just leave it in terms of K. All right. Now, how do we do this? First thing first, understand the question. So I understood that I should express everything in terms of K. So I don't really use cotangent theta. So if you use cotangent theta, like I initially thought, means you get stuck. Second thing is always, whenever you are asked to use Maclaurin series, look at MF26, your best friend in your exam, and see where should you expand to. This, you need to expand to the power of square, beta square. So stop at square. Anything above square, ignore, like b cube and so on, just ignore. So that's the second one. So from here, what I can do is I'm just going to bring my favorite MF26. I'm going to use cosine cosine and sine lah. So sine is this one. This is my sine. Then I'm going to use my cosine, which is, come on, yeah, this is it. This is a cosine. Okay, so what I'm going to do is, because I already know that I need to stop at b square, so my goodness, so fun, because I can ignore this, I can ignore the rest. So what I really need is just this is why you need to have a framework. Okay, so this is where you stop. So what I'm going to do is actually just going to do my favorite, which is actually just a cosine b, which is 1 minus beta square over 2. This is beta. Okay, then sine b will be kx lah. Yeah, rubbish. Kb. Okay, kb, kaopei. Okay, anyway, so this is a, this is 1 minus k beta minus b cube square minus 1. Now this, now why I move it to this form? Because what? Because this is power series. Okay, you need to use power series. And the problem is when students encounter this, they're like, oh, Mr. Khan, I can't do the power. This is your x. You see this as your x. So this will be using 1 plus x minus 1. Just like that. Okay. So anyway, or x, or that, okay, this is, okay, I'll write it as a 1 minus k minus b square over 2 plus minus 1 minus 2 factorial minus kb minus b square over 2 square plus dot. By the way, because you only need until the square, like what do you call it, or until the square of the expression, so you don't really need like this is 1, and you only expand this. Cube is regardless, so this is b square as such, right? So this is a 1 plus k beta plus k square plus half beta square. Ta-da! Okay, let me see, the answer is correct. K, and yeah, man, I got it. Okay, so m is what? M so this is equals to lah. So hence AB roughly equals to A 1 plus K beta plus K square beta square. Okay, hence M equals to K, M equals to K square plus half lah. There you go. M and N. Sorry, I need to go and learn my alphabet. So this is N. Okay. Right. Great. Now, if you can do the first two, then you should be able to do the third part lah. The third part is, given that further case 2, find the set of positive beta approximation point in part 2 to be valid given your answer in 4 decimal place. Let's try and understand this. Now, if you want the approximation to be valid, this is what you do. There are only 2 expressions in MF26 which has got validity, which is, one is the sorry, let me check. The only 2, one is the power series, and the other one is the ln. So these are the only 2 with validity. So what we are looking at is this one, mod x less than 1, whatever you substitute in. So hence, in other words, you just now sub in this, right, to be your x ma. So from the first, I'm just going to erase this, okay, because this is like a bit useless here. So oh my goodness, I hope that this is okay. I'm just going to copy this above so that I have more. Now what you're going to do is basically so since for it to be valid, right, for expansion to be valid, you get mod x less than 1, which will translate it to be kb mod b square over 2, which is actually just kb less than 2 lah. So what am I doing? I don't know what am I doing. Find the set of value for a function to be valid given answer in correction. K equals to 2. Okay, k equals to 2. So k equals to 2 lah. So this will be 2. Can I just mod the negative? Okay, so this is 2 beta plus beta square over 2 less than 1. Alright. Oh, then just use calculator lor. This just use calculator. You know how to use calculator. I'll just use calculator. Or should I use the manual method? It's calculator lah. Calculator easier. Okay, so you're just gonna use calculator. So here will be math, absolute value. So you just draw this graph here. 2 beta squared less than 1. So 2x. Let me draw this out. 2x plus x squared over 2 less than 1. So I'm just going to put 1 below here and just graph it. Zoom standard should be able to give me an answer. Ta-da! So we want this value here. I don't even know what we want. Beta is what? Beta is positive? No? Oh, positive value. Set of positive value. Yes. So from the graph, you know that what do we want? Less than 1, is it? Less than 1, is it? Yes. There you go. Less than 1 means it's here to here. Okay, so I'll just zoom in so that you understand what's going on here. Ta-da. So you are actually looking at the positive x value here, which is here. Okay, from GC. Solve this part. So calculate. Intersect. I'm just doing this properly. Enter. This is your answer, I think. Check. Here. Just solve that. This is inequalities. This is nothing to do with, okay, a bit to do with power series, but it's not like it's totally out of the league of the way. So this part here, you're actually looking at, this is beta. So this part here, positive beta, because beta is positive. So hence, from GC, beta is between 0.4495 and 0 lah. How many SF they have? 4 SF. Okay, great. F for SF. Yeah. Okay. So check your answer. Do you understand? This is a very common question. Always this figure came out quite often. So just practice it. Any question, please let me know. If not, I'll see you next lesson.